All right, thank you, everybody. We're now going to move on to the panel discussion. And I want to thank all of the participants for the great questions we've been receiving. We'll try to get through as many as we can. To get started, this is a question to really any of the panelists. How far do you think we are from the 1,000 float steady state? And what can the international community, including organizations such as Partnership for Observation of the Global Ocean, POGO, do to help achieve this?
I'll take a quick shot, Andrea. So the 1,000 float target is for floats with multiple sensors, 5 or 6 sensors. And if we count only floats in the water with that many sensors, we have just fewer than 200 in the water now. And so we're 20% of the way towards the global array. There are many more floats with single sensors, as Hervé noted, oxygen or biooptics. So 20%, we have a ways to go. Fortunately, GO-BGC will accelerate us towards that objective.
Yeah, good.
So I think this is a great question, Andrea. I think Argo has demonstrated that through its lifetime that it requires an extensive effort in a number of areas. It's not just deploying instruments. It's really a much broader fabric of development, of technology, the deployment of the Argo, BGC Argo floats. It's working with the modeling communities. It's involves education, training, and outreach. So I think there's a lot of space for communities like POGO to come to the table and contribute their relative expertise. And I don't think any organization is too small or too big. I think Argo has sort of demonstrated a great model about how the community can work together to develop this new, capability. But it's going to require a lot of help.
Great. Another question we received was about floats being deployed on ships and if that would be impacted as we tried to decarbonize and reduce ship traffic, et cetera. So could somebody speak to how floats may be deployed in the future?
I don't want to go too far. I think a great model for float deployment has been Argo's work with the New Zealand research vessel Kaharoa. 40% of the current core Argo array has been deployed by Kaharoa, which is only 28 meters long. And a much more efficient ship than sending a 100-meter long global research vessel to deploy floats. So I think there's a lot we can do. There are been efforts to use sailing vessels and so on. So we'll have to be innovative, but getting floats in the water is a challenge.
And I'll speak a little to that one too, Andrea. On behalf of the U.S. academic research fleet, we are always looking to right size the fleet. And certainly we have strong connections with the global research vessel community. We have had workshops on green ships, and I do appreciate the sentiment by 2030 to have a different world when it comes to carbon emissions throughout the globe. So we are working hard on that, but I think that there is still a lot of efforts to be done, and we do need the ships. We're not going to get away from the ships. Thank you.
So Andrea, let me just add to what Ken and Lisa said. I think there are also potential opportunities using the commercial fleets that are out there. We use them a lot for other assets that observe the global oceans that are deployable off of these vessels. And so trying to reduce somewhat our reliance upon these research ships would be a good opportunity, but it will require, I think, some effort on the part of the community to figure out how best to do that in a safe and productive way. I know we use the commercial fleet. We even use nonprofit groups who have research ships or communities who are all kinds. We'll take a ride anywhere as long as we can effectively deploy our instruments. We're happy to kind of develop those partnerships.
Great. This is a question for Hervé. Can you speak to how Argo influences coastal regions and the floats largely are deployed in waters deeper than 2,000 meters? Are there some connections there where the global fleet can contribute?
I would say that BGC Argo is the open ocean site for the moment of what gliders achieve from the shore to the open ocean domain. So I think that at the very limit between the coastal zones, maybe more integration between what BGC Argo are providing together with the gliders that provide the same kind of information in some way is where we should work in terms of integration.
Thank you. All right, Dr. Suga, this one's for you. How will Core Argo and BGC Argo decide on locations to deploy floats?
Okay, so yes, the all components, BGC and Deep and Core Argo should cover the entire global ocean with the, basically one float per 3 degree by 3 degree, and some area like tropical Pacific and some marginal seas and Western Boundary Current extension region should be more higher density. So depending on such density specification, we should deploy the BGC and core float evenly in a box, maybe 6 degree box. We should have 4 floats, 4 float including BGC and core. So we have to do some price. We should plan price precisely to do that. So it's more challenging compared to just a single core float.
Maybe I can add on to this point that there is an OceanOps that is a monitoring tool at international levels that will help to do this, and we will probably prioritize according to the difficulty that we have with core float, probably going to opportunity deployments where because we don't need ancillary data to be acquired together, while BGC float, for the moment, we need to have CTD or additional measurement. So we will prefer to have Deep and BGC float deployed from research vessels and the other float maybe more deployed from opportunity vessels. But we have the tools in place, it's just a matter to use them properly and to coordinate. That will be the challenge of the next years.
Okay, following up on that, and this might be a question for a few of you, but I'll direct it at Hervé, which is, what are some of the regions that are most critical for floats to assist with the satellite observations that we have that are largely global, but have some seasonal missing data?
So I would say all the area are interesting. So the first response is because BGC Argo is global. I think that the synergy is very nice with this respect. But for example, the North Atlantic, we know that it's a very important area in terms of biogeochemistry, but it's a very cloudy area. So the satellite, that they have their own observational gaps. And I would say that BGC Argo array would nicely complement in such area what the satellite is not able to see through at least the ocean color satellites through the clouds. So definitively, high latitude environment in general will largely gain of having in situ data.
Great. And speaking of satellite ocean color, we can come back to the topic Ken presented on, which was on net permanent production. There were a couple questions related to Dialcycles and how you extract that from floats that are profiling on a 10-day profiling cycle.
Yeah, so first of all, there is a paper that's gone through the first round of reviews at Nature Geoscience. I think looks like it'll be accepted. So we can extract the diel cycle directly. It's present in all of the data. There's essentially no assumptions in how you extract the diel cycle. There are assumptions in how you actually compute productivity from the diel cycle, but it's actually pretty straightforward. It's a great example of big data applications.
Great, thanks. So this one I'll direct to Maria. which is how can the G7 FSOI help advance the global biogeochemical Argo fleet going forward?
Yeah, the G7 is still a new entity for many of us in the ocean observing community, and we get asked about the G7. We often get asked how people can send proposals for funding. So we still have a lot of communications to do. So in general, G7 working groups serve as pilots or pathfinders in the G20 and the UN system to move forward science and technology issues that may be too complicated when you have a larger number of countries with diverse capacities and interests. And a key strength of the G7 FSOI is that it really serves as a unique forum that links the ocean observing community directly with the ministries and funding agencies that fund half of the observing system. And so by setting agreements on priorities for investment, like they've done for biogeochemical Argo, the G7 members can work with global partners beyond the G7 to advance the observing system through these sort of coordinated joint activities and coordinated investments. Each year, the G7 FSOI working group meets to discuss these priorities, and they only highlight a very small number of priorities to highlight collectively. So this means that when government agencies and ministries are bombarded with requests for funding, all very important, these agreements on the coordinated G7 priorities for investment can sometimes get moved to the top of the list. So that's the force of this leveraging of all of the G7 countries, half of the observing system funding or more, can really help to prioritize and move things together and keep those priorities on the radar screens of the ministries and the research agencies. So, for example, an outcome of this workshop we hope will be a concise G7 statement, a communique that we can circulate to government ministries and funding agencies and partner institutions to maintain the momentum and to ensure that the array delivers on this range of applications that we're going to be hearing about later this month, so that we can make the case for sustained investment in keeping the Argo program, all of it, funded and sustained.
Great, thank you. I just want to quickly address, I know it's we're on the top of the hour. We're going to go over by about 5 to 10 minutes just to get a few more questions in. If anybody needs to leave, that's fine, obviously. But I'll get to the next question here, which is perhaps for Lisa and David. GO-BGC is a big project funded for 5 years. Are there plans thereafter that you'd like to speak to?
So I'll hop on as NSF first, but very much want to acknowledge the partnership with NOAA and with NASA on delivering on all of these components. I love the conversation about, yes, it's the floats, but it's the data and it's the education and it's all of the different sensors for sure. Within the NSF space, we have recognized that there's sort of that $50 million mid-scale gap when we make our investments in large science facilities. I applaud Ken and his team for really taking advantage of that new opportunity with NSF funding to really match up a significant need for the ocean community. That is kind of how we do business in the NSF space. So we put the opportunities out there and we rely on the community to respond. Again, kudos to Ken and his team for really having the global ties in place to also make that a very competitive proposal and have the award. So I will say that we anticipate continuing to invest in this space. I think that we're very encouraged by the components that have been put forward and really just the impact and the cost-effective impact of the BGC investments. But I can't say that there are guarantees on the NSF side of the house. Thank you.
So, Andrea, if I could also comment, I would also agree with Lisa that we really like and enjoy the cross-agency partnership that we've developed in support of Argo now and in support of GO-BGC. And we hope to see that continue. At some point, we'd like to see the full integration, as Toshio talked about, the full integration of the Argo mission, And so in some sense, there's advantages to making sure that that's managed appropriately. I think it's from NOAA's perspective, at some point in the future, I would expect that many of these Argo activities would come under NOAA support at some point in the future. I don't know when that time might be. We've started to invest already in long-term infrastructure to help us do that. So we've just recently we've invested over $7 million over the last 4 years with some new hires, some career track hires within NOAA to develop and bring on board the expertise we need and to beef up our data systems. We would also envision some investment and capabilities in terms of routine product development and use of the BGC data. So I think we're in it for the long term, and we're eager to see this be successful over the next 5 years, and we'll go from there. Thanks.
Great, thank you. We have a couple of questions coming in related to how do we know whether the sensor data are good on a float? What is the latency in the quality assessment and quality control of those data, and how much human involvement is required? Maybe this one should go to Ken.
Yeah, thanks. So the first point is that the raw BGC data probably is not suitable for most scientific applications, but the tools exist to do the corrections automatically. So in the US, we correct the data as it comes in automatically. In the data files, all the data is there, the raw data, what we would call the Argo would call the adjusted data is there as well. And the adjusted data is suitable for nearly all science applications. Some months after the automatic correction is done, what is called delayed mode correction is done, where people look at the data and verify that the corrections are there. But basically, the real-time adjusted data is a very high quality. The comparisons I showed between float data and shipboard data are the real-time adjusted values, and those are of high quality. So how many people does it take to do that? Well, it is automated, but it does require a group of people to support the data center and do that. That is key to all of this. Part of GO-BGC is, and part of SOCOM has been building a group of really strong data analysts.
Great, thank you. I have a technical question for Hervé from one of our participants. Has there been any consensus on which optical backscattering sensors should be used on BGC Argo? They mentioned wavelength and angle. And do you find saturation issues with the sensors being used? For example, going into a coastal area where you might saturate the optical backscattering sensors?
So I would say that the first choice was the sensor, low consumption sensors that was actually developed by Seabird and formerly Wet Labs for gliders that were implemented on the floats. So the community is arraying of 3 backscattering sensors of this sort with a various angle from 120 to 149 or something like this, and that the wavelengths, single wavelengths of 700 nanometer. With respect to saturation, I think that the dynamic range is quite high. So the floats obviously are kept in the open ocean. When we see saturation, it's sometimes when we have animals that are attracted by the sensor, and we have backscattering that is saturating. But in very dense chlorophyll blooms or even upwelling areas, we didn't see any saturation yet.
Okay, so I think we're just about time, so I'll ask one sort of broad question that anyone can jump in on, which is what could be studied or better understood in 20 years as a result of the global BGC float array that's not possible now? Who wants to dive in?
I have some hopes that after the implementation of this 6 variable BGC Argo array over for 1,000 floats, we begin to go deeper in understanding of communities with respect to phytoplankton communities, to zooplankton communities, and these are the essential steps to go to fisheries. So we see that there are some sensors that are developed, low consumption sensors. So I think that there is some kind of potential for this.
You know, so today, most of the ocean, we don't really understand the seasonal cycles of chemistry of plankton off the surface where the satellites can't see, and the processes that drive that. In 20 years, we will have observed the seasonal cycles and the interannual variability and the physical processes that drive that interannual variability. And we will really, you know, as Hervé says, really have a strong linkage back to fisheries, back to the role of biology in driving the carbon pump in the ocean, and understanding how that varies from year to year.
This is David. I'll just build onto that. I would say in 20 years, BGC Argo will be one of the foundational monitoring systems for ocean health that enables ecosystem prediction and tracking of the ocean's component of the carbon cycle.
All right, well, thank you all. With that, I think we should conclude this session. I'd like to thank the speakers and panelists, as well as the audience, for their great questions. And so that will end for today. Check out the pre-recorded videos online and tune in next week for our discussion on how fisheries and fisheries management could benefit from a global biogeochemical Argo fleet. Thank you.